Hello everyone, this is Mr. McMillan. I'm here with an instructional video. This time we're going to be looking at a diagram of a circle and labeling and discussing the various parts of the circle. So we've already discussed the first three parts on this diagram that are numbered 1, 2, and 3 here. We talked about these when we talked about the equations of circles and circles in the coordinate plane. Okay, so first off, number one, the center. Okay, and remember that the center is the fixed point of a circle which is equidistant from all other points on the circle. Remember, equidistant just means that they're equally far apart, same distance, you get the point. Okay. And if you also remember, our center was labeled with an ordered pair HK when we did our equations. So if we look here in the diagram and we label what is the center, we see here that we have a center point here. And so we'll label that center, and you can label it with HK as well. Okay. All right, the next one that we talked about was a radius. Okay, so we needed a center and a radius to write our equations. So the radius is the distance from the center of the circle to any point on the circle. From the center of the circle to any point on the circle. Okay, so the radius always starts from the center and ends up on the edge of the circle. And when we labeled this in our equation, we used the letter R to represent the radius. So we use the letter R to represent the radius. So if you look here in this diagram, do you see any radii here? And remember, the radius always starts from the center. So if you connect a line segment starting from the center, you can see a radius that goes to point A, a radius that goes to point B, and a radius that goes to point C. Okay. So you can see clearly that these are all radii. Okay, so I'm going to label this one here, the one going to A, as my radius, which is R, but know that any point could have that happen. Okay. All right, next up, our diameter. Now, the diameter, if you remember, had a special relationship with the radius. And the diameter is always twice the length of the radius. So the diameter, D, is always equal to 2 times your radius, R. So if your radius is 25, then your diameter would be 50. If your radius is 42, your diameter would be 84, and so on and so forth. Okay, doesn't matter what your radius is, your diameter is always twice the length of it. Additionally, the diameter is the distance between 2 points on a circle where the midpoint of the segment is the center. Okay, so the midpoint of the segment is the center when you have a diameter. So in this diagram, do you see a diameter anywhere here? And you should see that segment CB, or segment BC, whichever way you want to write it, would be a diameter because it goes from point C to point B, and the midpoint of it is the center. Okay, so the diameter here, that would be CB on our diagram. So those were the three we talked about with the equations of the circles. Now we're going to talk about some new parts that we haven't covered before. And the first one is a chord. Now a chord is a segment that connects 2 points on a circle. So you may be saying, well, how does that differ from like a diameter or something like that? And it doesn't really from a diameter, because a diameter is also going to be a chord. That's because a chord resides entirely inside the circle. So a diameter is just a specific type of chord that passes through the center that connects 2 points. Okay, so a diameter is also a chord. Now, normally what we think of when we say that something is a chord, we are talking about ones that don't pass through the center, but just know that the diameter could also be considered a chord. So, do you see anything else other than the diameter that connects 2 points on the circle that's entirely inside the circle? None of it goes outside of it. And you should see that this line here, this line segment here, is entirely inside the circle, and it connects here and here. So this would be a chord because it's completely inside and it connects 2 points on the circle. Next up is the secant. And the secant is a line that intersects the circle at 2 points. Now, what's the difference between a secant and a chord? Because both of them will connect 2 points. Well, the secant passes through the circle, okay? The secant passes through the circle. So that means that it goes on infinitely. So for instance, here you can see there's a line that intersects at 2 points on the circle, but it continues onwards outside of the circle. So this line passes through the circle, connecting 2 points on the circle. So this would be a secant. So we're going to label that as a secant. And next up is our tangent. And a tangent is a line that touches a circle at 1 point, okay? A line that touches a circle at 1 point. So all it does is basically just skims the circle. It hits one single point and then it stays outside of the circle. So a tangent never goes inside, okay? Never goes inside the circle. So on this diagram, you should see down here that this line here only touches at this point here. So this would be your tangent. Now the point that the tangent touches the circle at also has a name, and that point is called the point of tangency. And so this point here is your point of tangency. Okay. Now there are 2 other parts that are going to be very relevant for what we're going to be doing here in the near future. But first we're going to talk about a circle and the most basic property that a circle has. And that is the degree measure of a circle. Now, most people will know this, you know, by the time they're in this class, because they've, well, been told to death that this is a circle, you know, what a circle equals. And the degree measure of a circle is always 360 degrees. okay? So the degree measure of a circle is always 360 degrees. So that means that from the center point, all of the angles around the center point would equal 360 degrees when added together. And you can see here that these arcs, right? These arcs, these points get or separate the circle into multiple parts. And all of those arcs would have to end up adding up to 360, okay? So when we talk about that here with the arcs, you'll see what I'm talking about, okay? Oops. So let's look at the arcs. And an arc is defined as any portion of a circle's circumference. Any portion of the circle's circumference. And the circumference, apologies for the lights, and the circumference is the outside edge of the circle. So the outside edge of the circle. So there are three different types of arcs. The first one is the minor arc. Now, when you think of a minor thing, you think of a tiny thing, you think of a small thing that's not very consequential. So a minor arc, when compared to the 180 degrees, is less than 180 degrees. So the measure of a minor arc is less than 180 degrees. So in this problem, do you see, or in this diagram, do you see a minor arc? Well, there are a few minor arcs here. For one, the most common one people will pick is arc AB. Another one that's a bit bigger but still less than 180 would be arc AC. So those are two that you see in here that have named letters, okay? So we would write that as AB with an arc over top of it, okay? It's very important to make sure you curve that so you know that you're looking at an arc and not a segment. Next up is a semicircle, and you may have heard of what a semicircle is before. A semicircle is half of a circle. So if you have half a circle and the measure of a circle is 360 degrees, then half of a circle must be equal to 180 degrees. So in this diagram, do you see an arc that would be a semicircle? Well, you should see that if you start at B and then travel along to C, you see that they form a semicircle when you go along that arc. So BC would be a semicircle. You could also use BAC for one, or CB, you know, whichever way you want to name it. The important thing about a semicircle is that it requires a diameter, okay? So a semicircle only exists when you have that diameter in there, because the diameter is what cuts the circle in half. Then your last type of arc is the major arc, and a major arc is greater than 180 degrees. So do you see an arc in this problem that is greater than 180 degrees? Well, if you start at A, then you go to B, that's part of it, but then we said BC gives you 180, so if you start from A, go to B, and then go to C, that is greater than 180 degrees. So arc ABC is greater than 180 degrees. Now notice we use 3 letters there to signify the major arc. That's to make sure that we are precise, whereas with a minor arc or a semicircle, we tend to only use 2. Now a semicircle can be 3, so can a minor arc, but they're much less common. And finally, the last bit here, a sector. A sector is any portion of the circle's area. So in the diagram, you can see this shaded section here. This would be your sector. Okay. So your sector is the shaded area of the circle. So we will be going into more detail with these types of things as the weeks go along. And please make sure that you continue to watch the videos and, you know, email me or contact me if you need any help with any of the concepts or anything like that. I'm more than happy to help. So thanks, guys, and I will see you in the next video.